Everybody. Thank you for the introduction. My name is Lane. Very, very excited to be here today and excited to talk to you guys about a topic that is very fundamental, very foundational to obviously blockchain, cryptocurrency, Web3, decentralization. It's a topic that we tend to, we all use the word decentralization quite a bit. We don't always, we're not always very thoughtful what we mean by decentralization when we use the topic. And so part of my talk is about the definition of decentralization, how we should think about it, how we should measure it, why it matters so much. And then I'll talk about decentralization in the context of Spacemash, my project. Very, very brief background on myself. I've been full-time in this industry for 7 years, kind of hard to believe, time flies. I was motivated to join the blockchain industry and begin working on Ethereum, which is the first thing I worked on 7 years ago, because I've always thought and recognized that blockchain, cryptocurrency, represents a really important platform, a really important tool, and a set of ideas that we can use to democratize access to these kind of global, decentralized, permissionless, censorship-resistant networks of value creation around the world, right? So basically democratizing access so that people everywhere can participate in these networks, create value for themselves, their families, their communities, et cetera. So before I jump to that, fun fact, my very first talk ever about Ethereum, about cryptocurrency, was right here in Taipei in 2017, 7 years ago, at an event called Beyond Block. Incredible how much has happened in the past 7 years. You know, at that time, it fit the entire Ethereum community in Taiwan into a room this size. It was about 100 people. Obviously, it's much, much, much bigger now. So I'm very, very excited to be back here. And then in 2019, I changed gears and helped launch a novel layer 1 blockchain called Spacemash. Still working on Spacemash 5 years later. We have a lot of work to do. In a nutshell, Spacemash is a novel layer 1 based on a novel consensus mechanism called proof of space-time, which is a bit of a hybrid of proof of work and proof of stake. Spacemash has 2 goals. The first is to make mining from home very simple, very easy, so that people can use, people all around the world who may not have access to bank accounts, credit cards, cryptocurrency exchanges, et cetera, they can use their existing hardware, their existing computer, their existing internet connection at basically 0 cost to become a miner on the Spacemash network and earn their first coins rather than buying them. And the second goal is to become the most decentralized blockchain in the world. We have a goal of having 1 million full mining nodes on the network. We're well on our way. Obviously, we still have a lot of work to do. And these 2 goals, being super decentralized, more decentralized than anyone, and being friendly to home miners, they're the same goal, right? Because the only way that you can have 1 million nodes in your network is by making it very easy to mine from home. Sorry, before I jump ahead, we launched Spacemash finally after 5 years of R&D in July last year, so the network is 8 or 9 months old. And I'm just very excited to be able to talk about Spacemash now, not just in theoretical terms, but in practical terms. And I'll show you real data from the network in a moment. So quick outline of the talk. As I said, we're going to begin by talking about decentralization. I will talk about it first in a theoretical sense and then in a practical sense in the context of Spacemash, the network. The main part of the talk is to present some challenges, right? It's called Why Decentralization is Hard, and what we're doing about those challenges, how to improve the network going forward, et cetera. So to reiterate what I said, right? We throw this term decentralization around a lot in the space. Everyone claims to be decentralized or be working towards decentralization, but we're not always very thoughtful what we mean about it. And this is what we want to avoid. Okay, not T-Rex attacking Taipei, but a dyno. And a dyno is a project or a network that is decentralized in name only. Okay, again, it's like, if we're not thoughtful about what we mean when we talk about decentralization, then we're going to end up with things that claim to be decentralized, but they're not really. The best resource I've ever seen to define decentralization, talk about what it is and why it means, is this blog post, this article from our friend Vitalik 7 years ago. It's called The Meaning of Decentralization. If you haven't read it, I encourage you to sit down and read it. It's not very long, and it's presented in a very structured way. If you have read it, then like I did in preparing the talk, I encourage you to read it again and reflect on it, because there's, again, a lot of really good stuff here. And most of the ideas I'm presenting in this section come from this article. I'll add some kind of commentary and stuff. So in the article talks about 3 types of decentralization. The first 3, logical, architectural, political. I added economic to the list. Logical decentralization is kind of like, you know, on the spectrum, right, is the thing that you're talking about, the network or the system, is it a monolith, right? Or on the other hand, is it more of like an amorphous swarm? And a good example of something that's sort of logically decentralized is a language, like the English language or the Chinese language or the BitTorrent network, right? You can cut them in half. You can take a population of English speakers, split them in half, and it's totally fine. They can still communicate and evolve separately. A blockchain is actually logically centralized because the goal of a system like Bitcoin or Ethereum is to create a centralized, a single state machine, right? We want a single global state, a source of truth about a ledger or the state of applications, et cetera. And this is why it's so important to be intentional what we mean when we talk about decentralization, because at least in this way, blockchains are centralized, logically centralized. Architectural decentralization or centralization is what most of us mean when we talk about decentralization in the context of blockchains. A simple way to put it is like how many nodes are in your network. It's more nuanced than that. It has to do with the versions of the software they're running, the node implementation they're running, the infrastructure they're running on, the operating system, et cetera, et cetera. I'll talk more about that in a moment. Political decentralization, I won't be talking a lot about it in this talk, but it's kind of like how many people or actors do you need to get in a room together to do something like upgrading a protocol or shutting something down. And I added economic to the list because in an age of proof of stake, I think it's very important and meaningful to ask questions like who controls the majority of the stake. You know, we have things like the Nakamoto coefficient, which is not a perfect measure, but it says how many validators together control enough stake to halt a network, right? Which is typically more than 1/3 of the stake. The article also talks about why decentralization matters. So Vitalik lays out 3 reasons: fault tolerance, attack resistance, collusion resistance. These are all important goals of certainly of Spacemash, as well as obviously of Ethereum and other decentralized networks. Fault tolerance is a very old idea. It's, you know, comes from way before blockchain. You see this in things like electrical grid networks or airplanes, right? They kind of incorporate elements of decentralization into their design to make them tolerant against certain types of faults. I alluded to this a moment ago when I talked about architectural decentralization. You know, you may have a million nodes on your network, right? You may have what looks to be something that's very architecturally decentralized, but in practice, if all of those nodes are running the exact same version of the same application, the same node, right, software, and there's a bug in that software, then the network is not very decentralized, it's not very resilient, right? So we need to look at many dimensions of architectural decentralization. As I said before, things like the operating system they're running on, the node implementation. Obviously, Ethereum is unique in having many node implementations. You know, you may have, again, a million nodes running a million different versions of the software, but if they're all running in AWS data centers and AWS is attacked or decides to, you know, deplatform Ethereum or something, or Spacemash, then you still have a problem. Attack resistance is like fault tolerance, but the types of faults that you're defending against are intentional rather than unintentional. They're very closely related. A good example of this would be like not a bug in your software, but a malicious, someone injecting malicious code into the software supply chain, right? That's something that happens. And again, if you have better decentralization, like for example, more implementations of your software, then there's more doors to knock on to kind of get malicious code into the system or something, and it makes it harder to attack. Collusion resistance is very nuanced. I encourage you to read the discussion in the article. I'm not going to go into this right now, but it is also a goal of these systems. Cool. So with that kind of background in place, I'll change gears and talk a little bit about how we're doing in building a decentralized network at Spacemash, which again is our goal. So this is our network dashboard. If you go to dash.spacemash.io in your web browser, you'll see this. It updates in real time. You know, a lot of pretty graphs here. We have just over 1.5 million smashers or miners in the network right now. I will talk about what this means in a second. The amount of space in the network, storage space, right? We use hard drive space for mining is, it's a bit higher than this. It's over 1 exabyte, which is pretty awesome for a young network. So the number I showed a moment ago, right? So this is something called miner identities. We're in the latest epoch, something like 1.8 million. This is really exciting, right? As a builder, as an entrepreneur, there's nothing more exciting than being able to stand on a stage in front of a room of people and point to a hockey stick graph like this and say, look, you know, this thing is alive, it's growing, it's very, very exciting. A couple things to say here. First is that this is like 2 orders of magnitude more than we expected when we were designing Spacemash. We kind of designed it for something like 10,000 miners in the network. And the fact that we have so many is really challenging. I'll explain why in a moment. So some aspects of decentralization are challenging. The other thing is like, these don't map one-to-one to real-world things like people or organizations or actors. The way the Spacemash protocol works today, it's very common for a single miner, as in like a single person or organization, to operate 100 identities, 10 identities, 100, in extreme cases, even 1,000. So we don't know the like number of miners in the network, but I'll give you some more hard numbers in a second that are indicative. I mentioned Spacemash uses hard drive space for security rather than what the resources used in proof of work or proof of stake. This is also growing really rapidly, which is really, really exciting. We just passed 1.5 exabytes. That's like 1,500 petabytes. It's a very, very large number. It's very difficult to kind of conceive of, but just to give you a sense of it, it's something like 350, 400 million songs. So it's about 3 times, I think, the size of the entire Spotify library. It's about 15 times the entire archive of the Internet Archive Foundation, which is around 10 petabytes, something like that. So 100 rather, sorry. Yeah, about 15 times that big. I think I had, it's approaching the amount of space, the amount of data stored in Filecoin, which is pretty exciting, right? Because again, Filecoin network is much older. Last time I checked, Filecoin has around 2 exabytes of data on the network. So I think this is really exciting for a young network. If someone wanted to like 51% attack Spacemash, they would need more than this amount of storage space, which is a lot, and it's growing, as you can see. This is kind of like the most interesting, I think, statistic, because unlike the miner identities, the node count corresponds to a real-world phenomenon, right? So this is like the number of unique nodes or peers that our infrastructure, our nodes, have seen. It's around 20,000. This is like a smoothed, aggregated data set, so don't pay too much attention to like the peaks and troughs here. This is pretty awesome, again, for a network that I think is, for a network that's quite young. It's only 8 months old. This is very similar to the number of Bitcoin nodes. It's around 2 to 3 times as many as the visible Ethereum nodes in the network. I think this speaks to the fact that we're trying very hard to make Spacemash easy to run from home. Of course, this is only the visible nodes in the network, and many nodes are like private, and so the actual count is much higher than this. So back to that dashboard a moment ago that I showed a moment ago. You may or may not have noticed there's this, I know it's a bit hard to see behind the table here, but there's this thing called a decentralization ratio, which says 82 right now, right? So what does that actually mean? This is a very kind of arbitrary, subjective number that we came up with, or equation rather, when we were designing Spacemash. It's a weighted average of 2 things. The first is how close we are to that number I said, we kind of designed Spacemash to support up to 10,000 miners, and as you saw, we're at like 1.5 million identities right now, so we blew past that goal. And then the other piece of it is the Gini coefficient of the weight of the miner. So basically the weight has to do with how much space that they've committed to the network. If a miner has 10 times the space, hard drive space committed, they have 10 times the weight in the network, basically. And so we want to look at like also how evenly distributed is that. The main reason I'm showing this is that like we were really wrong in coming up with this. This was like an early attempt to measure decentralization. I think it is important to try to come up with measures like this, but decentralization is very multidimensional. It's kind of like it when you see it, but it's very difficult to put a single equation on it. And I do not believe, and I'm not here to say that Spacemash is 82% of its way to the decentralization goal. Like maybe we're 10%, maybe 7%, I don't know. We have a lot of work to do. But it's worth trying to do, and if you have ideas about how to do a better decentralization measure, like come talk to me. Okay, the main thing I want to talk about is some of the challenges we're facing in trying to build a very decentralized network. The title of this talk is Decentralization is Hard. It's really, really hard. Take my word for it. So the first one, the most kind of unique, remarkable thing about Spacemash is the fact that we're targeting home miners. I've said this a few times. To the best of my knowledge, every other major blockchain has sort of node operators and miners who are kind of professional or quasi-professional. If you look at the people running Ethereum nodes, infrastructure, Solana is an even better example. They tend to be running those nodes on dedicated Linux instances, VMs, typically running in the cloud or running in data centers with a lot of bandwidth, et cetera. Like this is just not the case for Spacemash, right? The majority of the nodes are running on home computers, on home internet connections, and that's challenging for a whole bunch of reasons. One is that like the UX of mining is just not as easy as we'd like it to be, right? We have an application, a front end, you can download it, it's both a wallet and also a mining application. And in theory, you kind of like run it, you initialize your space and you just minimize it and it runs in the background and mines for you. In practice, it's never that simple, right? Because things tend to go wrong. People don't always keep their software up to date. There's very frequent updates you need to make. Your computer needs to be online 24/7, right? It doesn't really work on a laptop. You need a desktop computer with like a strong internet connection, et cetera. And so, the mitigation here basically is that like we need to take more of a product approach to Spacemash, or at least to the mining software. We are not product people, right? To be honest, we're like protocol designers and systems engineers. We just recently hired an amazing product person to our team, and like that's, I think, gonna make the home mining experience easier, but it's not gonna like just suddenly become easy overnight. Again, we have a lot of work to do there. The next thing is peer-to-peer. So I know way more gory details about like the way peer-to-peer networks work on the internet than I ever wanted to or intended to, because this is such a big part of what we do. Again, P2P doesn't work super well when you have a lot of home internet connections. You have private nodes behind NAT and this thing called CG-NAT, which is like a really terrible thing that ISPs do where they like just fundamentally break the internet by making it hard to operate servers and things from home. The modern internet, in a nutshell, was not designed to support intensive peer-to-peer applications. And it's, again, much easier if your nodes are running in the cloud on dedicated VM instances, et cetera. The good news is we're using libp2p, which is really great. Obviously, Ethereum and many other projects, Filecoin, et cetera, use libp2p. We have the support of that community, and there's a lot of low-hanging fruit. Like we know if we do things like hole punching better, the P2P network will get better. It will get easier to sync a node. The next thing is resources. So the way the Spacemash protocol was designed, it was a bit naive. Again, we expected maybe 10,000 miners, and the protocol is designed in such a way that the complexity increases linearly with the number of miners, right? And that's complexity measured in terms of messages, message traffic, bandwidth, compute, et cetera. Each of those miners needs to generate a proof of eligibility, which is a fairly complicated proof, and broadcast it to the network every epoch. And so it's already become very hard and very resource intensive to download millions and millions of proofs every epoch and validate them. The fixes here, like we know what to do, we're working on them. One fix is called distributed verification, where it will no longer be the case that every node needs to validate every proof. Another fix is allowing, as I said, some miners are operating, let's say 10 or 100 identities, allowing them to merge those identities together into a single identity, a single proof. So we know how to fix these things, but those are big protocol upgrades and they'll take time. But the resources requirements will come down over time. Pools are a very controversial topic in Spacemash, as they are in every crypto ecosystem. While putting this presentation together, I learned a fun fact that the first Bitcoin mining pool was launched in 2010, right? Which is something like, slightly over a year after the network launched. And at the time, of course, Bitcoin was tiny and had no value. It just goes to show that pools are part of every successful project, every successful protocol. Spacemash, like Bitcoin, like Ethereum, is permissionless. So we couldn't sort of ban people from running pools even if we wanted to. And pools take advantage of economies of scale. So they're not going away anytime soon. They are kind of a double-edged sword, because on the one hand, they give us a sophisticated point of contact. When we need to do things like coordinating network upgrades, pools tend to be technically sophisticated actors. And so that actually makes our lives a little easier than trying to convince a million home users to upgrade their nodes. But the flip side, of course, is from a decentralization perspective, both logical decentralization, political decentralization, et cetera, it's less than ideal. So we kind of have I'll share our thought process about pools. Again, they're not going away. We think having many pools is better than having one or two dominant pools. So we want to work on having open source pooling software to make it easier to operate competing pools. Very importantly, we need to educate users about the trade-offs of using pools, right? The fact that, for example, they need to give up their private keys to use pools. They're giving up sovereignty, and that's risky for a bunch of reasons. And we need to remove the non-economic incentives to join pools. So Spacemash is pretty unique in the way that even the smallest home miners there's no economic reason to join a pool because you will still earn, you're guaranteed to earn at least one reward every epoch. That's kind of our like key idea, key value proposition. But because running a node is harder than it should be, people end up joining pools, and we need to make it easier to run nodes. Finally, economics. This is a snapshot from basically a mining pool that operates on multiple ecosystems, including some like Chia that are also using hard drive space for mining. As you can see, it's still something like an order of magnitude more profitable to mine Spacemash than a similar protocol like Chia per unit space. Right now, the smallest home miners are earning something like $2 or $3 US worth of coins every epoch. So that's, call it, I don't know, $4 a month, something like that. That will probably fall by another order of magnitude. And it will be very interesting to see how the kind of shape of the curve, you know, of sort of the long tail of home miners relative to the smaller number of like larger scale miners and pools, how that kind of evolves over time as the economics plays out. But this is challenging, and there's no simple mitigation. We can't change economics. I'm kind of out of time. I want to save time for Q&A, so just to kind of conclude quickly, I said all these things already, right? These are basic things we're doing to improve the network, more of a product approach, making home mining easier, making the peer-to-peer network more robust, some big protocol upgrades that will be out pretty soon, continuing to remove incentive to join pools, making it easier to run many pools so that pools are competing, and educating users about the risks of joining pools. I could easily talk to you guys for hours about the VM. I am a VM engineer myself. It's what I was working on in Ethereum. It's the piece of Spacemash I've been the most excited about. I kind of put this together. It's just a jumble of things, but just to make it clear that like designing a VM from scratch in 2024 is not obvious. There are like a ton of dimensions, things to think about, right? Do you want to use an off-the-shelf blockchain custom VM like EVM or the Spacemash, the Solana virtual machine, Move, et cetera? Do you want to use a more global standard like WebAssembly or RISC-V? You know, layer 1 options, layer 2 options, different types of rollups. We're talking about Plasma now again. You know, where do you store your data for data availability? Do you care about privacy, et cetera, et cetera? We like spent years building a Spacemash virtual machine, and we threw the entire thing away a year or two ago because the goalposts had changed so much. The good news is our research team all met face-to-face last week, just last week, a few days ago, and we actually have now like a candidate full stack VM design. I should mention, we launched Spacemash in July, as I said, but without a VM, right? So for now, it's more just kind of a cryptocurrency. We wanted to kind of take our time and get the VM right. So we will be announcing, I think, Sunday, very, very soon, like this weekend, what our VM design is going to look like. I'm really excited to share more about that and talk about that. Yeah, that's basically it. Like I said, I want to save some time for questions. Resources you can find, I write quite often about Spacemash in my Substack. I'm active on Twitter and Farcaster. Spacemash website, our GitHub, everything's open source. We have a Discord, chat.spacemash.io. And finally, I'm really excited to announce that we're also sponsoring hacker bounties in the hackathon that starts here tonight. It's our first time doing this. So for any hackers in the room who are interested in kind of very bleeding edge protocol design, core protocols, things that are not proof of work or proof of stake, you know, it's the protocol itself has kind of stabilized, but we still need to build everything, okay? We need better wallets. We need to think about bridges and cross-chain stuff. We have an open-ended award, Hacker's Choice, like whatever part of Spacemash sounds interesting. If you're interested in hacking on it, please come talk to me. We've got some cool prizes as well. That's it. I'll leave you with a quote from Jaron Lanier. He's one of my personal heroes, one of the most brilliant thinkers in our space. And this just goes back to what I said in the beginning. I believe very strongly that we need to build a future where we have permissionless value creation networks, right? Networks that are permissionless, censorship resistant, credibly neutral, et cetera, that people everywhere can join and create value for themselves, their families, their communities, without those centralized arbiters like the way big tech social media networks work today. And this is my personal vision. This is the direction we're going with Spacemash. So more on that soon. Thanks for listening.
So now this is our Q&A time. Does anybody have questions for Lane? And Spacemash.
Uh-oh.
Yeah, don't be afraid. It's fine. No, I have a question that sounds a bit, yeah, silly, but I hope you can give me more details about, like, it will reveal more details about the way space-time, proof of space-time works.
Yeah.
You have in your measure of decentralization, everything is prefixed by 1/2 or 0.8. This is an
Yeah,
arbitrary.
it's a weighted average of these two things, and we just weighted them both equally. That's all that means.
Oh, it's both.
Yeah.
Oh, okay, that's why.
But again, these parameters are super arbitrary, and I kind of regret putting that slide in the presentation
Yeah.
because my point is like we need better ways to measure decentralization. So if you have any ideas, let me know.
Okay, gotcha. No, okay, that was it. Thanks.
Wow, I was expecting a harder question.
Give me a minute. I'll think about it.
Any more questions?
Hey, thanks for the talk. So, in terms of home computer as a node, do you tackle the question of information security, like when being know the IP will be public to the hackers? So, how do regular users or some dummies to deal with that?
Okay, so just to restate the question and make sure I understand, you're asking about for home users running Spacemash software, how do we protect their privacy, their IP address, things like this? Yeah, that's a great question. The short answer is it works the same way it does in Ethereum, right? So like you are revealing your IP address, but only to your peers, to your immediate peers. We do not have like a distributed hash table where all the peers in the network are, in a single table that gets gossiped or anything like that. Yeah, you're basically, you have like some number of neighbors in the network, and you connect to a boot node the same way you do in Bitcoin or Ethereum or something, and they give you certain peers you can try talking to. I guess you could run Spacemash through Tor or something if you wanted kind of better privacy. There's no reason you couldn't do that. But the other really important point to make is, again, like a network like Ethereum, there's some concern that if you could predict ahead of time who the block producers are going to be, you could like DOS attack them. And so we also have like a VRF kind of construction where block producers themselves only know shortly before they produce a block that they've been kind of elected to produce a block. So there's no revealing of any information about like who the block producers will be ahead of time.
Do we have more questions?
No, don't worry. It's not gonna be too hard. The first one is basically, adding to what the gentleman asked. If you do not have a DHT, how do you do your discovery? And the second one is, I saw in the list, so you say you selected, you know which VM you want to do, but I saw MIPS in the list, and I was wondering why you would even consider that.
MIPS is amazing. What are you talking about? Isn't Optimism's, what's it called? Their thing based on, anyway. So first question, the short answer is libp2p. Like we use their libp2p discovery layer. I don't think it uses a DHT under the hood. If I'm wrong, correct me. libp2p is awesome. So the VM, I mean, I'll go ahead and reveal a little bit because you asked. We're planning to use RISC-0. We're really excited about it. We've done a deep dive on, kind of all the options. Because we used to work together, that I'm very biased towards things like WebAssembly or RISC-V, right, that are kind of global standards and allow people to develop applications using their favorite programming languages. RISC-V, for people who are not familiar, has the benefit of being a very simple instruction set, like the name suggests, right, reduced complexity instruction set. It's also open source, right? Unlike, I think WebAssembly is, but like MIPS is not, for example, right? And we want to balance that against, on the other hand, being future compatible with ZK. So again, the details, I'll reveal all the details soon, but we're kind of coming up with a novel roll-up construction that's kind of enshrined at layer 1. It's going to be probably optimistic rather than ZK today, but we want to be able to do ZK stuff in the future, and RISC-0 seems like the best thing on the table right now to enable that. But you also told me about Powder. I need to look into that as well.
Okay, so because of the time limitations, so if you have any more questions for Lane, please approach him after the talk. Okay,
Thank you.
Thank you, Lane.